Antimicrobial resistance, a rising concern. Drug resistance has been an issue since the early 1940s, but has been increasingly apparent on a large scale in the last 20 years. Drug resistance arises in one of two ways. Bacteria can have spontaneous mutations in their genes that give them antibiotic resistance, but horizontal gene transfer, conjugation, transduction, transformation that we talked about before, that can give them antibiotic resistance as well. So they can pick it up from fragments of DNA, they can get it from a phage that accidentally picked up an antibiotic resistance gene from its previous host. They can have a neighbor who has a pilus that can give them that gene. But whether it's spontaneous or they get it from somewhere, the result is the same. That bacteria now has drug resistance. Antibiotic resistance genes are generally carried on the plasmids, the little circles of DNA. The resistance genes are usually called R factors for resistance. So, common mechanisms of drug resistance. Remember we said it'll attack enzymes? Bacterial enzymes keep the drug from working by making them inactive instead. So we used to have something that would go after the enzymes in the cell, and now I've got enzymes that literally kill the thing that goes after the enzymes. A decreased uptake of the drug. The bacterial plasma membrane will alter the permeability of the drug. Basically, I used to be able to get in, and now it's a lot harder. If I could get in very easily before, I could get a lot in and do what I needed to do, let's say to the ribosome inside the cell and inactivate the cell and kill it. Where here, all of a sudden, I'm having a real hard time getting in, which means I can't get to the ribosome and attack it, so the cell's fine. Ejection of the antibiotic. The antibiotic does make it inside the bacterial cell, but is immediately ejected. And there's a creation of a pump in the membrane of the cell that basically just keeps pumping the antibiotic right back out. Altered binding sites for the antibiotic. So remember, if I want to find a specific cell and attach to it, I have to have a binding site to get to. Well, if I'm an antibiotic and I use a specific binding site, and all of a sudden that bacterial cell doesn't have it anymore, I have no place to dock. It would be like having, a house with 10 bedrooms and 10 roommates, and one day you get home and 9 of you are standing outside because you don't have the right key. If you alter the lock, the binding site that the antibiotic goes to, it can't do its job, it can't get in. Use of an alternative pathway. The antibiotic works effectively, but the bacteria uses an alternate pathway basically to circumvent the shutdown caused by the antibiotic. So let's say that it attacks a specific enzyme and the cell is now using a secondary enzyme to do the same job, but it's not the exact same enzyme. So the antibiotic doesn't work on enzyme B, it only works on enzyme A. So enzyme A is out of the picture, but since enzyme B isn't susceptible to that antibiotic, the cell keeps working. Okay, more on antibiotic resistance. There are currently microbes out there that are completely resistant to every form of treatment that is available. One of the scary ones, well, actually they're all kind of scary, but one of the scary ones is drug-resistant tuberculosis. It was first seen in Italy in about 2009. It's been seen in other countries since then. All of our tuberculosis drugs are useless against this specific strain. Totally resistant, drug-resistant Neisseria gonorrhoeae is also on the horizon. Current treatments that we are using are the 3rd generation drug. And again, we're seeing that widespread resistance. People are coming in with gonorrhea. Now, mind you, Back in the day, gonorrhea, people would go in and, oh, you've got gonorrhea. Oh no, here's an antibiotic, take it for 7 days and they'd be fine. Now, if they get this drug-resistant version, yeah, you've got gonorrhea and we can't treat it. Other microbes are extensively drug-resistant, meaning they are resistant to several lines of defense. What can we specifically do to help with this issue? How can we narrow the possibility of drug-resistant bacteria existing? Can we control the population? No. Can we control what other people do? No. But we can control what we do. And we can control what we teach people. So the first thing that you are going to do, if someone gives you antibiotics, you take the full course of antibiotics. When you take antibiotics, it slows some of the bacteria's growth and it kills some of the bacteria. But those that it slows the growth of, usually they are already resistant. Taking the antibiotic keeps the numbers low and it gives your immune system enough time to kind of catch up and actually attack the bacteria that are kind of left over. When you stop taking the antibiotic altogether, let's say day 7, they give you 14 days of antibiotics, day 7 you go, I'm feeling fine, and you stop. Remember I said it slows the growth. Now they have free reign to explode in population because there's no more resistance to them doing that. There's nothing slowing them down. So when you recur, when you get sick again, and they try to give you the same antibiotic, it no longer works because what was left that you were kind of keeping at low numbers is now what everything is, instead of just being a low number that your immune system could take care of. If you take the full course over the 14 days, it slows it down enough that your immune system, like I said, has enough time to catch up. And once your immune system is involved, it'll kill it. But it doesn't have a huge battle to fight because the numbers of bacteria that are there are very small. Don't flush antibiotics down the toilet. They end up in the water supply. And as you know, in any water processing plant, there are bacteria in that water before it's treated. And you're exposing them to antibiotics. And it's like selective breeding. Those that are susceptible to it will die, but the ones that are left can now multiply because there's more room for them because the others are dead. There are drug trash cans at CVS. There are days at Walgreens where you can drop off your medications, and that gets them disposed of properly without putting them into the water supply, creating an issue where you're making drug-resistant microbes in that water supply. Third, don't share antibiotics with others. You saw that table and where the medications were effective. Just because I have extra penicillin tablets doesn't mean that they will be effective against whatever it is my mom is sick from. If it doesn't fall in the window of the treatment options for that antibiotic, you're taking it for no reason, 1, and 2, you're exposing things to an antibiotic and narrowing the population to only those that are susceptible to the antibiotic. Also, if you have a few left, you don't have a full course of antibiotics. You slow down their growth for a little while, but then you don't have the 14 days, 7 days of antibiotics, so they'll pop up, and now you've got a population that is completely resistant to the antibiotic that you didn't have enough of to get a full course of antibiotics. You are not, at least at this point, most likely, a pharmacist that knows exactly what's effective against what. You are also not a lab technician that has done bacterial culture to figure out what you're infected with. So don't give your medications to other people. Don't take antibiotics for a viral infection. They don't work. You saw all of the methods that these antibiotics used to effectively the bacteria. They attacked cell walls, they attacked cell membranes, they attacked ribosomes. Do viruses have any of that? No. So when you have a viral infection, there is no reason to take antibiotics at all. They don't work on viruses. And if you have a really good quality doctor, they will not give you antibiotics if you ask for them and they suspect a viral infection. With viruses, unfortunately, you just have to let nature take its course and let your immune system have enough time to kick in and kill the virus. When COVID first started and people kept asking for antibiotics, this is what popped into my head. My explanation that I just gave you was what popped into my head, because they don't work. They don't function the way that we would need them to function against a virus, because a virus doesn't have a cell membrane or a cell wall or ribosomes, or it's not building its own proteins. It's genetic material normally, maybe sometimes some enzymes, and a capsid, none of which antibiotics are effective against. Be patient with your medical care provider if they tell you that you've got a virus and they won't give you antibiotics. If it's a virus, there's a reason they're doing that. Remember, I talked about the bacteria that you have in your body? When you take antibiotics for no reason, the thing you are selecting against is the bacteria that helps to take care of you. And unfortunately, if they have one bacteria that is resistant to that antibiotic, and that bacteria starts to grow, most bacteria are opportunistic. It might actually infect you in a way that you don't want it to, because it's got the opportunity.